Hello, everyone. Welcome to Data Science and Snap. I'll be presenting my thesis work over the past year that I did in my master's during my time at UC Berkeley. And I think it is a very cool project. I think it is addressing a need that high school students have in the data science education sector. And I'm excited to show everyone what I've been working on. So I'll go ahead and share screen. So if you were in person, I gave a similar spiel on Tuesday, but I'll go ahead and work through these slides just to kind of give a general overview of what DASIS is. And then I'll be doing a short demo showing off what DASIS does, how it works, how students would use it, things like that. So DASIS is Data Science and Snap. It is a programming language within Snap, which is a block-based language used primarily in the educational sector. And I felt as though there was a space to create a library in Snap because data science education doesn't necessarily have to happen in a text-based language. I felt that there was an opportunity to provide students the ability to work in a block-based environment like Snap and be able to work with the same exact data science principles that UC Berkeley's Data 8 or other introductory data science courses talk about. Students don't have to spend as much time in that text-based environment learning syntax, learning how to run things, learning maybe having to download different libraries and different extensions. With Snap, it's all on the web. It's all free to access on the internet. All you need is a free account, and you can go ahead and start using Snap as soon as you do that. Because data science is so interdisciplinary, this material applies to any and all high school students who are interested. They can use it and apply it to their own interests. They can use it to as a jumping off point to further explore data science education in the future. It really is intended to be an introduction, a taste of what data science can be, and then students can do whatever it is they'd like with it going forward. At this URL, at this link, I have published my work. These are 4 modules that high school teachers can use in their classrooms with students. And these modules are, though they don't give a lot of automatic feedback, there are a few multiple choice questions where they do get immediate feedback. Any code that they write is currently not auto-graded, but the teacher of the class can work through this with their students. The students can work through it on their own. It is a very open-ended, it is a very, I think, versatile way to distribute the information that I've created about data science in Snap. It is under the umbrella of CS10. So it's through cs10.org's website, and you can click through all of the labs. They're very similar to how CS10's labs are at Berkeley. So students work through a process, it tells them what to do, they do it, they see how something works, and then they're given an opportunity to answer a more open-ended question and apply what they've just learned. A little bit about me. I just graduated from my master's degree in EECS under Professor Josh Hugg. It was a fantastic experience. I very much enjoyed it. I completed my undergraduate degree in computer science at Berkeley as well, and I got a minor in data science. Over the course of my time at Berkeley, I taught both computer science and data science courses. I worked on course staffs, I taught classes. I was very involved in the educational sector at Berkeley. I have developed DASIS as a part of my master's thesis project. I'm the sole developer, and currently there are plans in the works to get undergraduate students who are there now to take on the project and develop it further, where I will be taking more of a consulting role going forward in the future. So currently the DASIS library in Snap includes table infrastructure. So I established a table object that students can interact with and use to query tables, to organize their data. That infrastructure is all there now. That has table methods, that has table manipulation methods, all of the things that you would expect from either a data science library in Data 8 or SQL, things like that. There's also support for data visualization, which is my favorite personal part of the project, where we have support for bar plots, histograms, line plots, and scatter plots. In Snap's UI, I'll show it in a moment, but there's a section of the interface that is dedicated just to images, and that's where all of the data visualization happens. All students have to do is run blocks, and the visualizations show up on their screen. They can download those images, they can screenshot those images, whatever it is they'd like to do. They are free to to do what they'd like with the images that they generate. So loading a data science set into Snap, we have support for CSV importation. I'll talk about that in a moment. Snap is currently not available on Snap's default interface, but using the link that I provide, you can download the library and put it into Snap. And once you have it there, you can use it forever. All you have to do is save it in a file, and you'll be able to use it whenever you'd like. As I mentioned, there's going to be data importation via CSVs, and that will allow you to access the table methods and the data visualization methods that you're able to use on tables from there. So you import a data set using this variable that'll appear on the screen. I can show all of this off once we're there. In this menu, you can click import. That allows you to bring in any CSV. The only condition is that CSV should be cleaned data. Students at the level that my material covers don't need to know how to clean data like that. So you can, the library provides you the opportunity to clean it. It's just a little bit more complicated. So it's usually better to provide students at this level with a clean data set. You import the CSV, it will become a variable in Snap, and you can do whatever it is you'd like with it. So the table object itself has 4 attributes. It's a list of 4 items. There is the data itself, the number of rows in the data, the number of columns in the data, and a list of all the column labels in the table. There are several accessor methods that allow students to interface without having to know how the table object works or having to do some hacky solution to figure it out. All of these accessors do that by default, and they can use them just like this. And I'll show more of that in the demo. Querying a table is, as I mentioned, very similar to how SQL queries or how Data 8 queries. You have ordering, limiting, all of that functionality is all present as individual blocks that will be orange. And students do not need to understand how these functions work at a low level. They don't have to worry about how is it ordering or how is it keeping and filtering a table. They do not have to worry about that. They just click the block and all the work happens for them. So these are examples of querying blocks. They have this rounded oval shape. This means that in Snap, they're reporters, they return a value. And the reason this is important is because every single time they do these queries, they do not affect the original data set. So they may have loaded in a CSV that's very big and very high frequency, it's very dense. But when they order the table, it creates an ordered copy. It does not order the original table. They'll always have access to that original data when using these blocks. So they don't have to worry about making a mistake they can't undo. There's not very much permanence with these blocks. So they can do things. These are some of them. I won't list all of the functionality quite yet. I'll show that off in the demo. But we can order a table, we can filter a table, group, pivot, all the fun stuff that we know in data science. DASIS covers all of that. And this top block, this view table block, allows them to jump over the abstraction barrier and not have to worry about, oh, what happened? Why is it showing me this list with 2 numbers and 2 lists? They just click view table and they can see it. It looks similar to a spreadsheet in Excel within Snap. These blocks that have the notches, they're called command blocks in Snap. These do make changes to a physical table. So the data table that they import, if they use some of these, the table will be changed, which is very important to emphasize to students because it's very difficult to undo these actions. They have to be very confident in what they want to do, whether it be deleting a column, deleting a row, adding a row, these things happen permanently. So it's much more difficult to undo them. And while they can be very useful, students need to understand that they should use these with caution because they are difficult to undo, as I mentioned. The coup de grace of all of this results in data visualization. These 4 blocks implement bar graphs, histograms, scatter plots, and line plots for students. And the best part of these blocks is that they do not have to do a bunch of queries on a table to get to a table that could be visualized. All they must do is provide a valid table as input, the column or the grouping column, whatever other arguments they require for that block, and then bam, they click the block and it all happens for them. They do not have to do any extra work beyond that. And I'll show that off in the demo as well. So these are some of the examples of what data visualizations look like in Snap. We have our, again, bar graphs, histograms, line plots, and scatter plots. They can handle any size data set. I think the largest data set I tested on was like 15,000 rows. And these blocks still work at the snap of a finger, which in Snap is a fairly big deal because Snap has a lot of overhead due to its visual and block-based nature. And these are the default looks of those data visualizations. There are also more complicated versions like this that involve different colors, different numbers of bins and a histogram. They have all of those choices at their disposal, and they do not have to worry about how any of the, the stage visualization happens. They just click the block and it happens in the stage. So in conclusion, DASIS is intended to be this introduction for high school students, and personally, even to me, middle school students could be introduced to some of these data science principles. It's intended to be a way to provide access to any and all high school age students for data science education. They can do it on their own. They can do it with a teacher. They can do it with friends. It's all free to access on the internet. They don't have to do any additional downloading. There's no additional software. I really tried to make it so that the user experience would be as educationally friendly as possible. So I believe that if I had been shown data science in high school, that I would have been just as captivated as I was when I found it in college. And I'm just trying to provide that opportunity to find data science to even younger students. So yeah, before I get started with the demo, did anybody have any questions? I can check the chat. If not, I think I'll go ahead and jump right into the demo. One moment, sorry about that.
Can you like send us a link or something?
Yeah, I don't have it downloaded yet. I can send the link at the end, but for all of these things, you don't need to necessarily even have a Snap account. As long as I provide the downloaded file, which I can do at the end of the presentation, you can work with it as much as you'd like. So I'll get it into a form that people will be able to use.
Okay, but just so I understand, somebody could go to Snap and then find, this is like a plugin for Snap if you were to log into Snap.
Yes. So the suite of blocks that compose DASIS can be downloaded using an XML file that is, as I mentioned, on the website that I put all of my content on. And once you have that XML, you just drag it onto the Snap stage. You don't have to be logged in. You just have to be at snap.berkeley.edu. And I think this /snap/snap.html is necessary as well. And once you do that, you drag that XML file onto the stage anywhere here. It'll import all of the blocks right here, and you'll be able to use them as much as you like. So getting started, I have a data set loaded in, but if we were loading a data set for the first time, I could click this checkbox on the data set. I would right click and I can see this import button. You would then click on the CSV file that you'd like. Snap will bring it in. And then you use this create block. What this will do is create a table object, that abstracted table object that students can use. You provide the CSV data in this input. You save that as the variable name, and you end up with this penguin data, right? We have, as I mentioned, that first item is the data. That second item is the number of rows. The third item is the number of columns. And the fourth item is the labels in this.
Wait, you're using Palmer's penguins in Snap?
Yes.
That's so cool.
Absolutely. I can't wait to get to the data visualization portion of this, because all of those cool visualizations you've seen about these famous data sets all happen lightning quickly in Snap. So students can interact with it in a much more beginner friendly way. That as someone who learned in Snap myself, I can personally speak to how much of a great experience it was to learn programming in it. And though it's possible to jump straight to Python, I think that doing Snap first can provide students with a lot more confidence and can provide students with a lot more excitement for the material. So once we've done that, once we've brought in a data set like our penguin data, it looks something like this, but students should not click directly on the variable. They can, but it's better to use this view table block, which provides that more Excel style feel, where the labels appear at the top and all the data appears in rows below it. We can access the number of rows. We knew that there were 333 rows. We also know that there are 7 columns. These are accessor methods so that students never have to go directly into the object and access it like that. They don't have to worry about that. We can ask for all the column names. This is the data that's present in our table at the current time. We can ask for a specific column. So if we wanted to know the island column, we see that there are 3 islands present. We can ask for the first row. This corresponds to the first penguin in the data set. You can access these very similar to pandas or very similar to SQL. A lot of existing libraries were used as motivation, but I feel as though the implementation that we used in DASIS really plays to Snap's strengths for students. We can also query, so we can do things like selecting a certain number of columns from the table, and we can do that this way. For every single penguin now, we can see their island and their species, and it may be that we only need that relevant information for later. Definitely minimizing the amount of data you're using in Snap, like minimizing the size of a table that you're using is good, because Snap will only slow down if you don't minimize the amount of data that you're moving, the amount of memory you're using. We can also filter a table. So here we say keep rows from table in the penguin data set where the sex column equals female. That will give us only the female penguins all the way down. We can do the same thing if we wanted to say every row in the penguin data we want to keep if the flipper length is greater than 207. And this is a pattern we'll talk about later in the demo. But we can see that there are a few Adelie and a few chin straps, but for the most part, the ones with the big flippers are going to begin to. We can also order a table. So if we wanted to order all of the penguins by body mass, we can do that using the order block. And notice how I have view table on all of these blocks. That's because all of the outputs of these blocks are tables. And if you click directly on them, you're going to get that unabstracted view, and students generally get confused. This material has been demoed in a high school classroom. It was over the past semester, and students got confused most when they would do that. So this view table block is very necessary for visualizing tables. So here we've ordered by body mass, and so we can see the heaviest penguins at the top and the lightest penguins at the bottom. We can limit, very similar. This is just truncating the original table. And after doing all of these queries, notice that I can still go back to the top and view the table, and nothing has changed. This is the exact same data that we imported. We have not made any changes, any permanent changes. In this demo, I won't be doing any permanent changes to the table, but if you can imagine, we can delete rows, we can delete columns, we can drop a certain number of columns from the table. All of these things work. There's simply, for the sake of the demo, I didn't want to work with very many permanent changes. Oh, I got a question in chat. Someone tell me about the penguin data set. So the penguin data set, it has data about the dimensions of these penguins' bodies, so their flipper length, their bill depth, and bill length. I think there's also so body mass, and then you have the species of penguin they are, the island. I believe these islands are off of Australia, but I may be mistaken. And the sex of the penguins. It may also be Antarctic. I'm not sure where precisely the islands are. But
it's also an interesting social justice issue where the data set that was always used before was the iris data set. But that was associated with somebody who fell out of favor. So a progressive thing was to come up with a new data set to use as the demo data set, especially for data visualization. It got started by the R community, but now it's used broadly as like the new demo data set of the day.
Yeah, absolutely. The iris data set was useful, but I had heard the same thing, that the way the data was collected, the person that collected it, yes, I'd say a good way of putting it was that they fell out of favor. And so this is a very commonly used data set because the 3 species of penguin and the 3 islands provide us a great way to visualize groupings of penguins. So as I mentioned, all of these changes were not permanent. The original data set is still intact. And now we can open the door to some more advanced querying ideas and, more importantly, to data visualization itself. So when we group the table, the penguin data by species, and we aggregate using count, there are 3 options. We can either count them, we can add up all of the data that's aggregated, or we can take the average of all the aggregated data. So in this case, we're going to count, and this is expected functionality. All of the counts should be the same in every single column because every single column is present. This is clean data. We don't have to worry about missing values. And we see here that there are 146 Adelie, 119 Gentoo, and 68 chin straps in our data set. So this does give us the information we want. We got the count of the species, but a more intuitive way, especially for students to see that, is if we have this data visualization. So here we're going to make a bar graph using the penguin data, and we're going to go on the column species. And when I click this, all of that grouping that happened here, they don't have to put that in as input to this data visualization block. They can just provide penguin data and species. That's all they need to see this. And we can see that exact same distribution. If I click on this group table again, we can see that the Adelie are 146, the Gentoo are 119, and the Chinstrap are 68. Right, so these visualizations are purely for humans, as all of you know. The students do not need to know what's going on underneath. They don't need to worry about what's going on inside the block. All they need to know is that when they click the button, this is what happens. And so long as they're using the block correctly, they will be learning the same basic data science principles that you would learn in Python or you would learn in R. Another interesting correlation between the grouping block and the data visualization blocks. Here we will group the data by mean, and the two blank columns, the island and the sex, it is expected that these will be blank because they are string values. And the way DASIS treats those is, well, I can't take the average of strings, so I just don't put anything in it, leaves those blank. So that is expected behavior. For all the numerical columns, we get these average numbers. And for example, the flipper length, we can see each of them has, the Adelie and the Chinstrap have kind of similar flipper length, but the Gentoo seems to be a standout as a species. So we're going to see an example of how students would be able to visualize that using DASIS. So here we have 4 histograms that we're going to make. The first one filters for just the Adelie penguins. And if we do a histogram of their flipper length, we see that the average, as we expected, falls right around 191, 190. If we do the same thing for Chinstrap, we said that their flipper lengths were similar. We get a very similar average, right? Their average sits somewhere in that mid 190s range. But when we just look at the Gentoo, we see that that average, as we expect, creeps up, that it's closer, it's in the 210s. I believe the actual value was 217. So by seeing all of these individually, it makes more sense to a student that when they see the entire flipper length histogram, as we have here, there are 15 bins on flipper length, that we have this bimodal distribution with the left hump being a little bit higher. And that's because there are 2 species contributing to that left bump, and there is just the Gentoos contributing to the right one. And that explains the reason why there appears to be a dip in the high 190s and early 200s. So students will be able to do all of these things at just the click of a button. They don't have to worry about, oh, how do I group the penguins and then make it so that the bars know what they're doing? All of that happens to them like magic. They do not have to worry about it. They just click the block, as I've said many times, because as a student, it was always very frustrating having to twist different knobs and go behind the abstraction barrier. Students in DASIS will never have to worry about that. They just click away and they can do that. I got a question from Neil saying, how can we access Snap? Very good question. It's publicly available on the internet using any web browser. You go to this URL that's at the top here, snap.berkeley.edu/snap/snap.html. That will bring you to the default Snap page that has all of Snap's default blocks present, and you can use it to its full extent in that way. But to have access to my block, at the end of the demo, I'll go ahead and show you how to access DASIS using the website that I constructed for it. So the final thing I want to show off in my demo is the pivot block. So the pivot, the important part here is that even for grouping, we use the view table block to use it. We had to wrap it in a view table to be able to see it properly like this, because the object that comes out is a table. The object that comes out of pivot is not a table. And that is because this first column contains the second pivoted argument. So we can't use a table object in the same way to represent it. So you do not need a view table to click on pivot. You just click the block itself and it will show you this. We can see this distribution by species and by island. And if we visualize this using a scatter plot, or sorry, using a bar graph, a grouped bar graph, I put the species as the default grouping, which is why it appears on the y-axis, but the island also appears in the legend as the different colors. And so when we look at that pivot column again, we have that 44, 55, and 47. Here we have that 44, 55, and 47. And then we have the 0, 68, 0, and the 119, 0, 0. So students will be able to make these visualizations. You'd be able to say, well, based on the species, which island? You could ask a question like, which island do most Gentoo penguins live on? Or which island do most Chinstrap penguins live on? And you'd be able to answer that question using these bar graphs. And all the student must provide is a table and the proper inputs, which are usually text. And that's all they need to be able to visualize this data in Snap. The last thing that I'm going to show that's separate from the querying is the scatter plot functionality, which I see is very cool. The reason why the data set partially is so famous is for an introduction to machine learning ideas. And looking at this scatter plot where on the y-axis we have build depth and on the x-axis we have flipper length, there seems to be two distinct clumps. But initially, if you were to ask students, why are there two different clumps, you may not get a straight answer from the group. But using this optional grouping argument, if we group by species first, we can see that there is a definite pattern between the two, that the chin straps and adelies float in this, this clump or this cluster, and this huge cluster down here is all Gentoo. So if you were to provide a student, if you were to ask them a question simply saying, I have a penguin that has a flipper length of 215 and a bill depth of 14, which species of penguin do you believe it is? And students would, use their finger to move over, move up and say, oh, I think it's Gentoo. And that is a slight introduction to how machine learning works on some level, that a computer can learn things from data without knowing anything about penguins. The decision you make there, you're not a biologist, you don't have a background in special penguin knowledge, but you're still able to make a conclusion based on the data. And I think that's a super important topic to talk about this. I have a question here, I'll read it for a second. Okay, so addressing Uma's question, I think the most important way that students can interact with this is in a small way at first. So they'd be given a data set and they're given a question to answer. You would say, how many Gentoo penguins are there in the data set? And they use every single kind of block that they've been exposed to the best of their ability to answer that question. That it wouldn't necessarily just be checking for correctness of, oh, did you just get the correct answer? But the process of how they get to that correct answer is also very important. And that's something that my modules cover, that you should really approach a question. Data science is all about answering questions. So you should really approach the question and saying, what is it that I want to know? And what tools do I have that help me get to the point of being able to answer that question using that data? So the expectation for students isn't to be able to create this huge report, right? They don't necessarily need to just write lines of code that generate all these photos. And that's not, I don't think that's the objective that I would want high school students to have. I think it's more important to just pose questions. That's a lot of the activities that the students have. And the questions can get progressively more complicated and more difficult. But with all of the tools that they will have been given on their tool belt, they'll be able to, without as much help from the teacher over time, be able to say, oh, I know how to do that, right? If I wanted to count the number of Gentoos, first I filter for just the Gentoos, and then I count the number of rows in that table. So they'd be able to make that connection. And the teacher would really just be there to answer questions of, why is this not working? How does this block work? I don't understand or I don't remember. The teacher can be there for that, but it is intended to be a little bit more student independent in that way. And as you mentioned with clicking through, that is the first part. Generally, students will have to just see 3 or 4 examples of how a block works before they go ahead and use it themselves. They can be told what it does, but the best way to learn these things is to just see it in action. So something like this could be helpful, right? Where a student sees, oh, that's how a scatter plot is generated, and oh, that's how a bar graph is generated. So the teacher doesn't have to code any of the DASIS blocks. All of the DASIS functionality will work from there. Teachers will have the liberty from that point to be able to say, I want this data set, and then they can generate their own questions and expect students to answer them in a specific way. So the freedom and the liberty there really goes to the teachers in saying, what data do I want the students to work with for a project, and how can we use that the same way? In the modules that I created, I chose specific data sets for them to work with. There's a specific set of questions based on that data that students can use, but the teacher from there can branch off in almost any direction that they want. The modules they stop at the point, for those of you who are familiar with data 8, my modules stop right before probability. So we don't have conversations about statistics or probability or any of the mathematical data science principles. I really tried to provide them the data science principles pertaining to programming and really computational thinking is the best way I can summarize what I'm trying to give to these high school students. And by the time they have those programming skills and those thinking skills, they can move on to mathematical conversations. They can move on to machine learning topics, all of the various, subtopics in data science that exist. Students will be able to choose where they want to go from there. All right, so really quickly, I can drop the link in the chat of my content. So that's where you can find all of my modules, and you can feel free. It's all publicly available online. You can interact with it. You can do what it is that you'd like. And I really encourage teachers not only to teach it themselves to their students if they have the time, but feel free to share it with anyone and everyone that you know who teaches, and anyone and everyone you know who is of high school age. The more people who see this, the better. It's all free as long as you have access to the internet. And I think it is a fantastic opportunity to show high school students about data science before they get to college. All right. So that's about all I had prepared. I think we have a few more minutes if people have any questions or if people have any comments. I can stick around a little bit for those. But thank you for having me. This was fun to show everybody. I got a question. Can you say something about how using Snap in this data science context facilitates learning programming later? So in my experience, I learned programming outside of a data science context. I learned it in just an introductory CS context. But I think that introducing students to the kind of thinking, it is really, I want to hammer home that computational thinking point of thinking in a way that will get you closer to your solution. And the programming skills that people pick up along the way is being able to string together a series of blocks or a series of arguments or commands together in a row that get them from point A to point B. So students don't have to bother building them. The building process was my thesis project. So it is very complicated, and I would not expect students to have to build those things from scratch. The point of the course is to be able to provide them with those functions that already exist and have them use it on different data sets. So if they're provided a data set, I have one about taxi cab data in Manhattan. And you can ask questions like, what was the average tip that people left? Or what was the average distance that was traveled by all the taxis in the data set? And they would be able to have all of those pre-existing blocks at their disposal to be able to answer that question. When I say that the blocks are SQL style, in that they implement different parts of SQL's pipeline. So there's an ordering part, there's a limiting part, there's a selecting part. So students will have all of that built in just like they would with SQL, right? In SQL, they don't have to worry about actually pinging the database and sorting those things on a data row by data row level. It's really just constructing the query that gets them from the entire data set down to the answer to the question that they have. That's a good question. So as I was saying to Ming's question, that those programming skills that they would acquire in learning how to get from point A to point B in a data science context translates very well. I helped teach a class called Data 6. It was in spring and summer of 2021 that really it approached data science from a very programming perspective. But like I've been saying, that the focus was very much on the way you can think computationally. which doesn't mean, oh, just think like a computer and think very rigidly, but it does attempt to say, how can I get from where I am to where I want to go? And the programming skills you pick up along the way are, oh, okay, so I found that when I do this first and then this, it doesn't work. But when I switch the order or when I change the argument type, okay, things start to work. So it really is a lesson in using tools, using software that already exists to accomplish your goals. So if someone wanted to learn programming afterwards, they would have already been exposed to things like lists, strings, integers. They'd have more comfort with those primitives in coding languages. So the question here, so in some sense, you have queries prepared for data sets, and then they can choose queries that they would like to ask and then use the corresponding block. Yes. So I could say something as explicitly as, itemize, first order the table, then filter the table, then select the following columns, then find the certain item. You could do it that way. But the idea is that over time, you'd have to have less and less of those explicit English to code translations. And you could just simply ask a question like, which penguin is most populous on the island of Torgerson? And they would just have free range. They have all of the tools available to them. And it's their job to figure out not only which tools are correct, but how to use them correctly and how to get to the answer of the question. Does that make sense? All right. So it was a lot of fun getting to show everyone. If there are no further questions, I think I'm gonna take off. But yeah, I hope that you feel the need to tell this to as many high school teachers as you know, spread the word. It is all free to use. There are no strings attached with that. I really just want to get this to as many people as possible.